Good afternoon, hello and welcome. Good evening, good morning to our online attendees. This is the electrical room introduction presentation of use cases and discussion. The speakers you will hear from are shown on this next slide, and the session is scheduled to last 90 minutes. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to our speakers, I would like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration of this session. If you wish to ask a question, please use the chat box in the control panel. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust code of conduct. Now we'll hand over to our speakers.
So good afternoon to the many people in the room and the many people online. I don't know how many people we are online.
We don't have a number.
No, it's okay. Okay, so the objective of this workshop is to share with you what we are doing in the electrical room that we are representing here. So this electrical room is a new room in buildingSMART, and our ambition is to investigate what needs to be done in the domain of electrical staff. I will explain later on, in order to improve efficiency in the construction, sustainability, and create sustainable buildings. So as I said, we are now called and named electrical room. When we started this room last year, we were initially called sustainability and energy management room, but we realized that it somehow created some confusion. As it was said yesterday morning during the plenary session, everything and anything we do in buildingSMART is about sustainability. So why we would be the one to claim we do sustainability? So that's why we want to just make it simple that what we address in this room is really about the electrical domain. So our primary focus is the electrical power network within the building, the distribution network, the different players in there, and of course, sustainability and energy efficiency remains our ultimate goal. So our vision and mission in this room is, first, thanks to all the great job that has been done in buildingSMART for 4 years, the open BIM is now a reality in the construction domain. But, and there is a but, we consider that there is still a lot to do, first, to bring what the open BIM is to the electrical trade, because there is, I would say, the electrical players, electrical contractors, panel builders, different persona that we have in the electrical trade are not at all familiar with what is going on in the BIM process. And some of our people, if we ask them what is BIM, they don't even know what BIM is. So that's one way to bring the BIM domain in the electrical trade. And on the other hand, bring into the BIM, the open BIM, all what is specific to the electrical domain, which is also lagging. So create a kind of IFC electrical, if I can say, is what is our vision. So our ambition is to enrich the IFC, the VSDD, with what is needed for electrical staff in order to bring interoperability, exchange of information, and at the end, bring sustainability. So what is in the scope, and first in terms of process? So as I said, we have a specific and dedicated list of players in the electrical domain. You can see the list here. Of course, we have some shared one with the building, like architects. But then when it comes to engineering during the planning phase, electrical engineering or electrical planners are generally specific. Then electrical contractors are just dealing with cables and electrical staff. We have some people such as panel builders who are creating the sub-assemblies, the system that we need to bring into this BIM process, as well as we have some system integrators to finally come back to what we all share, building owners, operators, and facility managers. So when we talk about electrical domain, what are we talking about, and what is our primary focus? So what we want to address first is everything that is electrical and attached or hosted in or inside a building. So it will start, if I imagine there is a start, it can start by electrical production for a building, dedicated locally to a building. Imagine we have photovoltaic panels on the roof of the building, or that there can be a windmill inside or on the roof as well, or close to the building. Then it can be the power supply somewhere down in the ground floor with the incomer from the power utilities, the transformer, and then all the distribution networks that would go from the main switchboard through all the distribution up in the stairs, and finally the final distribution network going down to the plug-in sockets, going down to the lights, and to all the push button and stuff. So all the electrical network within a building is what we want to address primarily. We know that there is what we call the grid, so the power supply, if we think about smart cities and so on, that can be addressed, and that some other would like to address, but we start first with the building. So what we want to deliver, we will explain it around the use case, but we are convinced that there is first a need for interoperability and exchange. So starting with things that we all know in this building smart environment, having shared dictionaries, common dictionaries, having open BIM formats. This to be more efficient in the design, construction, down to operation, so that we can exchange information and bring a seamless, continuously digital workflow between all the players I mentioned earlier. And here is one specificity I already pointed out, is that we have electrical trade players such as electrical contractors, panel builders, that we need to bring into this BIM modeling. Is it an approach or know-how or habits? They need to come into the BIM. So that's about dictionaries, exchange model. At the end of the construction, the ambition is also that we have a digital model. We were speaking yesterday of a digital twin horizon 1 or 2 or 3, but we need something digitally machine readable that represents the electrical network within the building, with all the relationship with the building. Where is my switchboard located? How do I control the light? Which is related to the space and the type of rooms and things like that. So that is about the electrical network and all the components that we need to have inside this data model. But it doesn't stop here. We said at the beginning that our ambition is energy efficiency and sustainability. And this model of the electrical network is, for me, the digital model that will give the context that will come with smart device. Imagine that you have a power meter and you know that your consumption and this power meter has been so many kilowatt last month. First thing we need to know is, okay, but where is that meter? What does it measure? Does it measure the HVAC? Does it measure the lighting? If it's the HVAC, it's the HVAC for the whole building or just for this part of the building? So this is the kind of information that we can, and we need to retrieve machine readable again from a data model. First thing. And second thing is this meter has given a consumption of 1,000 kilowatt or whatever you want last month. Is it good? Is it what was forecasted? We need to have this to know if our building in the last month was efficiently operated as forecasted. And here again, we need to offer the capacity to have a machine-readable model, but the model also that can feed some simulation capability about energy consumption. So that is what we envision in this electrical room. So where are we today? So this room is new, a bit less or a bit more. Let's say €1. So we started this room with a joint initiative pushed by Schneider and Siemens. So two, I would say, leading manufacturer from the electrical trades, joined by some partners such as ER1, who is also here, or Bernd from a consulting company. And we first started as a very small team, having our own workshop, and we started to define what is same as we have to do at the end, our own dictionary. When we talk about electrical players, what are the phases we have in the electrical domain? How do we call them? Because there might be some slight differences between the electrical design and the building. We don't call the same thing. The personas also in the different countries, we call them one way or the other. So we needed to share our vocabulary so that we all have a common definition of roles and phase. Then we also work on the BPMN mapping. I will come back to that also, of the different phase, the different deliverables. And now we are reaching the stage that our activity proposal is being refined, and we start to define the use cases that we will present now. Which use cases will lead to the next phase. Our ambition is to have first working package on use cases, identifying the use cases. We will show you the process later on, so that we can, based on these use cases, identify the properties that we need and that are missing. So the use case will feed the BSDD, saying, hey, this property doesn't exist. This object, do we have this object in the IFC? Oh no, it's missing. Or this property is missing. So assessing what is available today in the BSDD in the IFC for the electrical domain, then feeding some IDS, populating some use case management, and see how we can model it with IFC or some complements that we need to bring to IFC. So that's basically the plan, and we will have a busy semester until the next meeting in Lillestrøm, where I hope we can share more about these results. So for what the use case are concerned, as I say, the first thing we did and that we can share is, as you can see on the screen, we have this pretty complex process map. What is important to retain in this process map is that we have the definition of the different phases with an electrical point of view. We have the definition of the personas. So you see the one we have, the architect, the electrical planner, the electrical contractor, the panel builder, which are specific, sorry for them, animals that we have in in the electrical trade. And we started to map the different interaction between the different players at different phases. So that's where we are now. And the use case are now, let's say, I am an electrical contractor and I am expected to receive this kind of information at this stage from home. So this is the principle of the use case we define. Use cases are identified on the BPMN process map. In the way to phrase the use case is first, who is the person receiving the information? What is the information he is expecting to have and what for? And in terms of software or platform, what platform or what software would this information be extracted from to feed what kind of software? That's basically what the process we follow. And we also identify that doing so, at different stages, we may have similar use case that we decided also to group in use case set to make it a bit more simple. So we have a backlog of use case. As you can see here, we started to map them. So the wish list in red is still big. And there are many more to come because we just started. And we will present here this afternoon just 3 use cases at the beginning, at the middle, and at the end of the design and build process, just for you to illustrate and see and get your comments on the way we are proceeding, plus one concept that will be in the next workshop, which is the tech box concept that Bernd will present. So use case 1. The use case 1 is at the very beginning. So the phase is the preliminary design of a building. So the architect has started the design of a building. We know where the building will be located. We know the shape of the building. We know how many floors, the type of rooms, the usage. So I would say shouldn't use this term, but the SketchUp of the meeting is done. There is something here. And as an electrical planner, I have to design my electrical network. So as an electrical planner, I need to be able to identify what is the load demand of the building. So here it's about the usage, the number of square meter for meeting room, the number of square meter of kitchen, the number of fine cold unit or things like that. I need to sum up the demand load. As an electrical designer, I may also want to simulate the photovoltaic consumption. So here you start to see the interaction with the building. I need square meter. I need to know the location of the building because the production will not be the same if I am in Rome or if I am in Helsinki. I need to know what the architect allows me to use as a surface to put PV panel because maybe he has some aesthetic constraints and he doesn't want to have photovoltaic panel everywhere around the building. So there is a lot of interaction here between the design and the electrical staff. Then as an electrical designer, I need to know where I will place my equipment, where I will route my cables. So then I need to lay out my network, but having a kind of synoptic, if I can say so. And here starts to have some regulation. There are some standards that impose to have a barycentric calculation of the different major equipment just for the sake of sustainability, which is make sure that we don't overconsume cables. So let's stay close together. And barycentric calculation comes back to know where exactly the location inside of the building is. So that is basically this first use case. And here is the illustration of what I just said. And we tried to discipline ourselves to frame the use case in a user story, as we do in software development, which is as electrical planner, I need to get this kind of information. And this is what I just explained. In terms of next step, thanks to this explanation, we also want to write down what is the level of information needed in terms of geometry. In that case, what do we need? We just need to know the square meter per type of usage. The level of information, what is the information we need? So here we probably need to have somewhere how many watt per square meter for office space, how many watt per square meter if it's an hospital room or whatever we can imagine, so that we can simply design, as we have on the right-hand side of the screen. It's not yet what we call in the electrical domain a single line diagram. It's more a general architecture of the electrical network, single line diagram and so on. We'll come to the next use case.
Okay, thank you.
That Oliver will present.
Oh, sorry, my microphone. So thank you for overhanding me. The second use case seems to be very simple, because it's a use case between the electrical planner and the architect. So it seems to be very easy or simple, because the architect just need to know if he has enough space for the electrotechnical equipment in his building or not. For example, if regarding power distribution board, if there's enough space in the room or not. But if you regard the details afterwards, step by step, it could have a lot of consequences. For example, not only the spatial discussions, but at the end you also need analysis, for some weights, for example. Or if a power distribution board is sent to the construction site, if there's enough space to integrate it, to bring it on the construction site. And so at the end, it's a use case in different phases, and we regard in the first step, the phase 5. That means the electrical planner needs to implement some IFC data with all these informations to spatial discussions. And so so the architects need information, as mentioned, the space of a power distribution board, for example, or also the power busbar trunking systems, which is also important. Maybe in discussion with other trades, maybe. Also some weights. If the room is right dimensioned or not. But also heat dissipations. That means, do I need to regard some specific ventilation, or do I need to regard some specific rooms in front of the power distribution board, for the maintenance processes, or also for the evacuation processes, And so, as you see, step by step, the details are getting more bigger and bigger, and more important for all these aspects, how the equipment is running through the operational phase or not. And so at the end, we need to integrate a lot of information for different aspects. And that's what we are discussing in our concepts for each use case. And here, as mentioned, just the weight, the dimensions, but also what is inside, some specific environmental information, for example. That's what an architect needs to regard in a very early phase. And here's just an overview to get a better feeling what we are talking about. Is it just a power distribution board, or do we need to regard specific aspects, like distances from the wall for the heating? Do we need to regard some specific electrotechnical connections? From busbar trunking systems to the power distribution boards, and so on. And all these informations are integrated in the IFC file for this use case. And so I would hand over to Rolf for the third use case. Thank you.
Okay, thank you. At first, it is a pleasure for me to show you what we described for the use case number 3. And I must say it is an honor for me to work with these guys together since 1 year with this high experience, and I think we described a lot So the use case number three, we said this the use case, we call it provide an enclosure or switchboard and metadata for electrical to a BIM model. So from who is coming this information? The panel builder deliver the information like the geometry, like the content, what is in the switchboard, the components from the manufacturers, the connectivity, the electrical connectivity, the communication connectivity, data, and so on. And the export sources are electrical panel, CAD or CAA engineering tools like our tool from ePlan, the Pro Panel, or from Schneider C Electrical. And who receives the information? The information goes to the electrical installer for what? For geometry inside the building, for location, cable information, and so on. And I will go a little bit deeper later. And import tools for this switch cabinet could be Navisworks, akka, Revit, and so on. So where we are in the whole process, Bertrand mentions that we describe the whole process and we divide it in the different service phases. And the use case I talk now is in service phase 8, and we have 2 touch points. The first touch point is when the panel builder brings the panel at the first time to the installer, to the building, and the second touch point is when we make some news, some changes during the building phase, and so on, and the panel builder make an update of the switchboard. So let us go a little bit deeper in the process. So what is exactly the panel builder do? And it is very important that we know the panel builder don't design the panel for us for building information modeling or for buildingSMART or for exchanging the data. The panel builder use the tools to manufacture efficiency their own panels for manufacturing the cabinet, for manufacturing the drillings on the board, for something else. But when he design it in 3D, it is a very high advantage for us to use it inside the building. So he can, after designing his 3D panel with all the connection, with all the components, components inside, he can bring the panel to the EEPC or to the installer, and the installer prove it and make changes and bring all the information back to the panel builder. And the use case we are talking here are on these 2 steps. And it is important that we say what we are doing, what we are talking about. And it is also important that we are talking what we are not doing here. We are not talking here how do the panel builder get the information to build the panel from IFC. We also don't talk about how do the EEPC installer place the panel inside the building. We don't talk about how do the installer bring the information to the general contractor or to the operator to prove it again. And we don't talk how gets the information back from the proof concept to the panel builder. These are important in the whole value chain, and these are different use cases. We explain here 3 use cases, what we have defined, and other use cases will follow, and these could be other use cases we define later on. So what is with the panel? Here, this is an example for a final switchboard coming from our ePlan Pro panel. And what information is in this switchboard? At first, we have the geometry for the collision body. We have the insert point for the switch cabinet. We have, for example, we have the weight from the switchboard when it is built with all the components and so on. And on the next step, we have also all information about the component are in the switchboard or in the panel, with all the information about the manufacturer, with all the information about the load and so on. And we have also all the information about the connection later on for cabling to connect the cable to the switchboard, because the switchboard is the connecting point between the component inside the building, like the socket or sensor and so on, and the functional description, like the schematic of the room, and is also the connection point to the management system later. Okay, so and these are some information we can transport, and as Bertrand mentioned also, so we describe every point what is inside the use case. We will describe it exactly. I hope we can do it, and we also describe who is the sender, who is the receiver, what is the software who is come from, and who is the software who receive it. And these are the use case number 3. So, and now I will hand over to Bertrand back and to the audience. Yes, for questions.
No.
High voltage systems.
What
was the boundary?
Yeah, so if we go back, no problem, because it's here we are. So the boundary is we start with everything that is inside and attached to the building. Let's take it this way. We start by that, and there is already a lot to do. So we can say it's mainly low voltage, but and especially as we target sustainability, it must include the photovoltaic production, windmill, if there are some generator, of course, in case of emergency generator or UPS, storage eventually. So the objective is really to design an efficient building. We know that this building is part of a grid, but that's another domain we can address second. And also this other domain is already addressed by some other standards, especially for the grid. There is an IEC standard 61850 that describe this pretty well. So we don't need to do it if it's already done.
Sorry, that's what you get when you contemplate.
Yeah, no, but it's a very good question.
The other question is, are there bridges to be made? Because I think we're living, we're on archipelago islands of standardization. Otherwise, if you know, this community, the electrical community, is heading this way, and others are heading that way.
Right.
So I think I will. Is it okay? Yes. I think this is here in Rome. This is the right place to connect together. Yes, the last months we start with our own mind, with our own way. But this is one of our biggest goal, to get in touch with all the other rooms and to discuss. And we hope that somebody maybe here in the room is say, hey, we have something defined and we can work together.
And at the end, we have always connections to different trades, because every trade needs a power supply, and also consumption of the power. We need to regard in our engineering processes. So you see the overlapping. But in the first step, we regard just the internal power distribution system, and step by step we need to extend it. But as Rolf mentioned, we are looking forward to get connected to other rooms. For example, building automation rooms, would be really necessary, but also as a grid discussion. Outside our buildings, there's also a power consumption. There's also a power distribution. But in the first step, we regard just the power distribution inside the building.
Yeah, and maybe to add something to that, because Bertrand said that we have also a fourth use case, which we call a tech box concept. We will discuss in the next session, but just to give you a glimpse. So we are talking about also defining some transition data to other trades. So that you say, for example, HVAC, fire safety, whatever. So it's not our domain, but what we want is to provide at least the necessary data to work together, to collaborate. But that's all we're doing. We are not going into detail on the other domains.
And also the other point is that if you think that electrical network, electrical power is a service of the building, so it means that we had the decision this morning to create what they call the corridor. I don't know if some of you were in this meeting about sustainability, because we cannot claim we only manage sustainability. So we have to debate and exchange with other rooms. Also, in the use case, we need to describe electrical objects. So we will have to go back to the BSDD and say, hey, this is missing somewhere. So we need to put this kind of properties. With the product room, same, we need to define things. So there are many, many different interactions that we must have.
That would have been my third question, is because your domain has an excellent basis in ETIM that has been there for a long time, and also has been transferred successfully into the BSDD. Is this what covers all your information needs? Is ETIM enough, or will there be?
There is a gap. ETIM, if we just speak about ETIM, is suitable for products. So I can find good enough properties to buy a circuit breaker, a relay, whatever electrical product from a distributor. But when it comes to a switchboard that Rolf does explain, what are the properties we need for a switchboard? If it comes to a medium voltage substation, which is not distributed through the distributors as Rexel and Sonepar, so which are not really addressed by ETIM, do we have this? In ETIM, Oliver mentioned that we need to give power dissipation or some technical information that are needed for the building, because I need to size my heating or my cooling of my technical room. If it's a data center, that's not in ETIM. So we need to find some additional information somewhere in a dictionary and in a database.
But our idea is also, of course, to use also information which is already existing. Yeah, and if you regard the external standards, how we call it, yeah, ETIM, E-class, CDD, whatever, yeah, they are very good information already existing. Yeah, and so not why to use it also in defining some use cases. Yeah, but the focus is different. Yeah, on the one side, ETIM E-class, for example, has a device focus, yeah, and we have the system focus, yeah. And our idea is now to bring it together, yeah, information which is already existing, to implement it in a use case, and add on some information, but to think also about how to bring it back maybe in other standards afterwards. Yeah, and at the end, if a use case is defined, each information needs to be consistent. Yeah, in BSDD, in ETIM, E-class, or wherever. Yeah. It's also interest of our companies, for example, Siemens, Schneider. Yeah, we need to support the external standards. Yeah, because otherwise we have no chance to create all these data. Yeah, and that's why we are really interested in the interconnections. Okay.
Any other question? We have plenty of time.
I have a question, because I understand that you are concentrated in the building, and you want to work these use cases at the end to have this all built to digital twin. But and do you expect it to exchange that to grid and power to X and so on? Do you have a time for that? Because if you want to work step by step, maybe could be, yeah, be plenty of time.
Yeah, so we have just started, as Bertrand has talked about it. Yeah, so we have defined now the first 3 use cases, and we need to learn how to do it. Yeah, so we have defined our process. That means, how do we define use case? We have defined the regulations. So each use case needs to be unique. Yeah, and then after the Rome summit, the next step would be in the room. Yeah, to define a specific roadmap. Yeah, and that's a time perspective, step by step. And we think that when we work out together the first use cases, maybe the first 5, 6, 10 use cases, we have an experience how long it takes, what is need to be done by whom. Yeah, and so we are on a good way, I think. Yeah, but of course we do not have a final roadmap at the end. When you ask me, we would have so many use cases in the future, many years. Yeah, if you regard the entire process, yeah, from the first idea up to the demolition of a building, yeah, there would be enough work for the next 10, 15 years, I think. I fear.
Probably that's the next, but we already started the next discussion or debate we can have in the room, but also with other room, is what are the use cases that hurt the most? What are the use cases that are the most urgent? So that we could take this to deliver the first deliverables. Would it be on the dictionary or one things as soon as possible? Because it's true that if we wait to have all the properties, that will be impossible.
Maybe something to add to that. So that doesn't mean that we first try to collect all use cases until we have everything, and then we start to consider what to do. No, the idea is to go through with every use case and bring it to work, and not wait 10 years before we start. No, the idea is to start now. And with the first use case, we try to define what we need, and then we try to implement it. I think maybe that's
we start the process now. Yeah, that's the topic. Yeah.
If you look at the use case we presented, the 3 use cases are very much dimension oriented. It was about size and volumes and things like that. If we go and speak to an electrician down the street, he doesn't see the electrical network in dimension. When he thinks a network, he sees a diagram. And as I said in the introduction, we need to bring the electrical network to the beam, or the electrical trade to the beam, and vice versa. So we also will have to address things speaking to the electrical trades with diagrams and so on. And then ultimately also, Oliver mentioned it, the electrical network is powering the different application, but then there is a control of the application. And if we want to address efficiency, it's about control and how I control depending on the usage, which is yet another layer, if I can say. There can be a physical layer, an electrical power layer, and a control layer or point of view.
I don't want to waste.
Please don't stop with questions. Yeah,
I don't want to. But so in the HVAC component, so we're working at the university in Aachen. We're working for a number of companies like Viessmann, Trox, Hilti. So people that do heating and ventilation foremost, and they had this German standard VDI 3805 for the Germans among you, which yes, so which now becomes lifted onto the ISO stage, and which now also is going to be mapped into including the behavior and the combinations of product configurations into IFC, and making this inventory of what's possible. But you're working in these groups as well. Okay, and that's also some requirements to simulate behavior and to simulate and to make these combinations. Okay, so then
this is very important for us to work also there in the Arbeitsgruppe VDMA, BIM, GA und ET. Yeah.
Okay.
So It's in German, sorry. Yes, but we are working also there. Yes.
Because there, I think there's so much work to do, and it would be great to have another branch of industries.
What for me is interesting when we work in this different associations, like also the VDMA, and here in our room and in E-class, I think we do in every association the same work.
Yes, and that's
define the value chain, define the value chain, define the use cases, and so on. Yes.
Yeah. Thank you.
Any further questions? So the summit is still running. Yeah. If you have any questions, don't hesitate to ask us, especially at the evening, maybe also. Yeah.
Just well, maybe one last important point for you, but also for the people online. If we look at who we are yet in the room, we have manufacturers, we have software editors. Well, the thing we are missing or lacking in the room is users. To your question, what do we will start where? What will we start with? Where does it hurt? It would be good if in the room we could have a building operator. There was, unfortunately, I invited people from Schiphol, but or an hospital to tell us this is what we need urgently. So that's a call for contribution and a call for help. If you are a building owner, building operator, join us. We need you.
Yeah, but I think that's exactly what you said, Bertrand. So what we really want to do is to do something that can be used. So we don't want to build up some theoretical scenarios. We really want to make it work in practice. So it's an important point to make.
So if you are an owner, what would you expect from us?
Yeah, indeed, you were mentioning something about the metering system. We have a big problem with that. We're currently integrating.
Yeah, exactly. Because when if where's the machine? Yes. If I go next, what Rolf showed us, where? I hope I didn't click too many times. No.
Oh, I love to click.
Here we go. So this switchboard represented it on the mechanical aspect. But if you think about it on an electrical point of view, one connection point here will be one circuit that will be feeding an HVAC, a boiler or a chiller or lighting. And inside of this switchboard, one of the components will be a meter. And that is the information we need to provide, that the function of a meter is here on the circuit that is hidden somewhere inside the switchboard, but the circuit is running around the building and feeding the HVAC or feeding the lighting or the kitchen or whatever. And that's what we need to bring. I was mentioning the different facets of an electrical network. It can be a physical staff. It can be a logical staff, like for metering. It can be the cabling. So that's a point. Because at the end, we need a machine-readable model that will enable you to say, okay, I know this is a meter. It has a UID, and I have the context. I know that it's feeding the HVAC for this part of my building. That's exactly what we have to propose.
And the answer is also, we regard all the phases, not only the planning phase and construction phase, but especially, of course, the operational phase of a building. Yeah? And during the operational phase, building management system, especially in smart buildings, it's getting more and more important. Yeah? And the power distribution system within a building is really important to save all the functions. Yeah? And so at the end, we are always need to analyze what kind of power do we have? Is everything running or not? Also service activities, the predictive maintenance activities, that's all relevant for smart buildings. And so step by step, we need to rank all the use cases, planning phase, operational phase, anyhow, at the end, also the dismantling phase in the future, maybe, But yes, we regard all the use cases also for the operational phase.
And you see here are sitting 4 young guys, and we have free place there. So we invite, I think this is the top line.
Of dating the building between the electrical side and also the BMS side. Let's say that we are currently organizing who's the owner of what, because the metering is also connected, let's say, to a BMS system, so it's in BACnet. The other system, it's only in BIM, so we have, let's say, a big issue in that part. So it's really nice to see that, let's say, you're taking already the initiative of getting that ownership also here in buildingSMART. I mean, yeah.
Yes, and we with our work we are connecting 2 different worlds together. So one we have the location inside the building about the socket or the panel or about the sensor, and we have a functional description who is the basic for a management system. And what we we bring these 2 worlds together. Thank you, Oliver. Don't hesitate to contact us during the summit, and it's a pleasure to me to us to talk with you and to get the mind.
Thank you. And also, of course, we're going in detail then in also on this tech box concept. Maybe it could be also interesting then for you.
Yes.